guys. Okay, so the other day there I asked you to complete this circuit. Okay, so I'll do it for you right now. This is a simple circuit. That means there's one cable going around, connecting to one thing, through another cable to another thing, and then back round. Okay, so there's simple circuit. So now if I attach this, what you should see is that both light bulbs light up. Okay, you probably can't see it very clearly, but what it should show is that this light bulb has more light energy than this one. It's not as shining as bright. And the reason being is because the electrons coming out of this cable are going in here, charging and giving energy to this light bulb, so there is a higher amount of energy going in than there is coming out. So there's less energy coming out here. So this less energy is now going to this light bulb, and it's shining this light bulb, but it's not getting the same amount of energy as the first light bulb. Okay, so, and then it goes back in, right? So this is what this shows, a simple circuit. If I added another light bulb here or over here, it would be the exact same thing. The next light bulb in this simple circuit will not get the same amount of energy as the first one. So it should show that it will go from light, bright to dimmer and dimmer, okay? What would happen if I remove a light bulb? Well, it's pretty much like what happens on your Christmas tree garland. You know the lights around your Christmas trees? They're the same. They work on the same principle. It's one piece of metal, copper metal, attached to a light bulb after a light bulb after a light bulb. So in a metal, in your Christmas garland, what happens if you take one light bulb out? If one light bulb blows, boom, there's no circuit. It's been broken. And the reason being, your light bulbs here have a little metal element here. So what's happening is when you put the metal from this cable, it comes in, it touches the metal on your light bulb, which then connects to the next one. Okay, so this is what this is. If you take the light bulb out, what it's doing is breaking the metal chain, the flow of the current, okay? And the conductivity. So if you put him back, boom. So that's why when you have Christmas tree lights, if you lose one, well, they all go out. So it's a pain, huh? You have to spend your time looking for that one light bulb to make them all work again. Okay, so now I'm going to quickly show you what a circuit would look like. We've looked at our simple circuit, okay? Boom, boom, one connection to the next, to the next. Okay, simple circuits. So if you see it, it's just pretty much one cable. Today we're going to concentrate on parallel circuits, okay? And if you can see, it looks very different, huh? Look at the difference, okay? So this light bulb's connected to this light bulb via cable. But if you look at this one is not connected to the next light bulb at all. They've got their own separate circuit, okay? I'll put this here. And this is the formula you see in houses. If you're getting your house with electricity, this is how it works, guys. It's like this. So this is one light bulb to another light bulb, but you can actually add more light bulbs. So in your house, you've probably got like 10 light bulbs. And they're in a series of a system called parallel circuits. Okay? And I'll show you the reason why. You'll find out the reason why. But the good thing about these guys is if you look here, you've got one cable going in, but it splits before it gets to the second one. So they're both, not attached. They're not attached to each other and they're not dependent on each other. So, but what you could do is I could put a switch here. If I put a switch here and open the switch, okay, what's going to happen is there's no current going to any of them, okay? They're not going to get any energy. If I close the switch, they will all get energy. But in a house, it doesn't work like that. You've got a switch for every single light. So we'll look at this here. You've got a switch here, a switch here, okay, and a switch here. So if I wanted, I could leave this switch open, close these two switches. This one's getting energy, this one's getting energy, but this one's not. So this light would go on and this light would go on, and this one would not be on. So do you see the importance of this? Okay, so I'm looking at your simple circuit. If you take one off, they all go off. But in your parallel circuit, you have more control. Okay, so now your job for today is to create a parallel circuit on here. I'll get started to show you. So what you do is you put your posts here with your light bulbs in it, and then you connect one to the next one. Okay, so they're parallel, but they're still getting current. So yeah, you see this, how this is working on here. One to here and then one to there. Then you would connect them again here, and then you would connect this last one to here and to the battery. Okay, so your job today is do that. Show me some screenshots of your final score and your final results and tell me what happened. You need to explain to me what's happening. But what you could also do, once you've completed your circuit, take a light bulb out, put it back in, take a light bulb out, put it back in, and tell me what happens. Okay, so your job today is to carry out this interactive circuit, a parallel circuit with 2 light bulbs, and tell me what happens. Okay, thank you.